everyone, so in this video we are talking about the quadratic formula. Sorry if my board is kind of spacing out and changing colors, it's just being weird today. Remember, there are many ways to solve a quadratic equation to find the solutions, also called roots, zeros, x-intercepts. We've talked about many of these ways. So we've talked about graphing, but sometimes it's kind of hard to graph. We've talked about the square root method, but that doesn't always work. We've talked about factoring, but it doesn't always factor. So today we're talking about the quadratic formula, which literally lets you solve a quadratic, and this always works. So when in doubt, you can always use the quadratic formula. The good news is it's on your formula sheet, and it looks like this. I would memorize this one because you're going to actually use this in the future. You're going to need to know this for future math classes. But if you don't want to memorize it, or if you forget, it is on your formula sheet. It's on the very bottom left. So we'll talk about it in a second, but first I want to just mention formulas are literally like a roadmap, and when you come to a symbol, you just put in what it represents. For example, see if you can take a second, pause the video, and try this little puzzle. Alright, so hopefully you've tried it. It would be never let diamond as anyone, so you put anyone in for diamond. So never let anyone. Little horse here is treat, so treat you like a yellow, and then star, and then burst. You are a pink star burst. Anyway, this is literally a formula. You take out the symbol, you put in what it represents. This is the same thing. You follow it like a roadmap, and every time you come to a B, an A, or a C, you put in what it represents. The A, B, and C come from your quadratic. The A is whatever's in front of the x squared. The B is whatever's in front of the x, and the C is the constant. Everything has to be on the same side, and if you're ever missing something, like if we just didn't even have an x term, then B would be 0. Or if you didn't have a constant on the end, C would be 0. Okay, again, it's on your formula sheet, bottom left here, and it even has the standard form written out for you as well. So if you need reminded, it's ax squared, there's A, and bx, there's B, and C. And that's what you put into the formula. Note that this often gives you two solutions, the plus and the minus version. Just by the way, this is how I remember it. It's like Pop Goes the Weasel, but quadratic formula style.
The quadratic formula's negative b plus or minus the square root of b squared minus 4ac all over 2a.
I literally sing that in my head as I'm writing it out. Okay, so we're going to go through 3 examples on this one. Again, I want to solve it. I want to find the values of x that make this equation true. And I think this one may be factors, but we're going to use quadratic formula. Again, the A is whatever's in front of the x squared. In this case, it's just a 1. The B is whatever's in front of x. In this case, a 4. And the C is whatever is on the end by itself, which is a negative 21. They need to be in order for it to be like A, B, C. All right, then I'll just fill them into the formula. X equals negative B plus or minus the square root of B squared minus 4AC over 2A. Okay, there we go. Again, just go step by step, filling stuff in. So negative B, I'm going to fill in negative and then whatever B is, which is a 4, plus or minus the square root of B squared, so 4 squared, minus 4, there's always just a minus 4 there, and then times A, which is 1, times C, which is negative 21, all over, and it's all over 2A, and A is 1. It's not just this divided by that, it's not just this divided by that, it's all over 2a. All right, a couple things. I use parentheses because especially with negatives, parentheses help. Like this is not minus 21, it's times a negative 21. I want you guys to just simplify your answers as much as you can. Don't get out of decimal, but just simplify the radical. So we're just gonna take it one step at a time, simplifying as we go. We can't type it all in our calculator because of this plus minus anyway. So here I have negative 4 plus or minus. This square root might not come out even. It might not square root evenly. But all this stuff I could put in my calculator. Like I could type in 4 squared minus 4 times 1 times negative 21 all in my calculator. Or you can do it one step at a time. 4 squared is 16, and then do all that and then add it together. I'm just going to type all this in my calculator. So 4 squared minus 4 times 1 times negative 21, which is actually 100. And I have not used the square root yet. I just did all this and it became 100. 2 times 1 is 2. And we're getting a little closer. Just going to keep simplifying one step at a time. So I've still got negative 4 plus or minus all over 2. The square root of 100 is 10. And at that point, the square root's gone because I just used it. All right. So this is my answer, except for I'm going to need to split it up at this point because my answers are negative 4 plus 10 over 2 and negative 4 minus 10 over 2. And those are going to give us 2 different answers. So at this point, I'm going to go ahead and split it up. Sorry for the board. So we've got negative 4 plus 10 over 2 and negative 4 minus 10 all over 2. Again, it's all divided by 2. So you're going to need to do the top part first. Negative 4 plus 10, which is 6 over 2, which is 3. And then this would be negative 4 minus 10, so negative 14 over 2, which is negative 7. See how those give me actually 2 very different answers. So once you're done simplifying as much as you can, you got to split up the plus minus. Sometimes you won't have to, you'll see that later, but if I'm going to get out number answers, you'll need to split it up. Remember, you can always check your work. If you want to take 3, does 3 squared plus 4 times 3 minus 21 actually equal 0? Same thing with negative 7. Let's try another one. You'll notice on this one, it's kind of hard to identify what the A, B, and C are because everything's kind of jumbled. So the first thing I want to do is move it all to the same side. It doesn't matter which side you pick, I'm going to move it this way. So subtract 50 from both sides. So I've got x squared, 49 minus 50 is minus 1. And I'll also add 2x to both sides to move it over here. So now I just have 0 left. All right, if you had it like this, you gotta be careful. This is kind of out of order. So when I'm identifying A is whatever's in front of x squared. In this case, that's a 1. When I'm trying to find B is not just the next thing in line. B is whatever's in front of the x. Really, I should have rearranged those. I should have written x squared plus 2x minus 1. Because this is B, it's in front of the x, and this is C. Also, keep in mind, A, B, and C are just the numbers, the coefficients in front of the variables. They don't include any x's themselves. All right, so now let's plug that into the formula. So we've got x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. just filling in my a, b, and c to the formula. That's usually the easy part. The harder part is simplifying all this mess. Once again, I kind of take it in 3 steps. Deal with this, and deal with this separately. So I've got -2 plus or minus the square root. I'm going to type all that in my calculator. So 2 squared is 4, minus 4 times -1, which is plus 4, so that's just an 8. And 2 times 1 is 2. Alright, we're almost done. 8 does not square root evenly, like the last one did. So we're not going to get any real numbers as a solution, any integers. Sorry, we will get a real number, just not an integer. 8 does break down though, and so we want to break it down and try to simplify a little bit. I don't want you to get a decimal out, but I do want you to simplify radicals if you can. So 8 actually splits into the square root of 4 and the square root of 2. And the reason I did that is because the square root of 4 is 2. So now it's 2 root of 2. Basically, I'm just going to replace 8 with 2 root of 2. Because remember, the more you can get outside the radical, the better. So now I have a lot of 2's going on here. With fractions, you can always split up a fraction over the denominator. Just like if I had 1/3 plus 1/3, that's the same thing as 2/3, because I have 1 plus 1 gives me 2 all over the same third. Or if I wanted to take this and break it back up, I could split 1 plus 1 into separate 1 plus 1's. Basically, I can split up this numerator over the denominator. So I could do -2 over 2, and then this over 2, and leave the plus minus. Basically, just divide them both by 2. So -2 over 2 is -1. These 2's cancel, leaving just square root of 2. And that's the final answer because I can't simplify any more than that. Square root of 2 doesn't break down at all. There's nothing to divide by. Again, you could get a decimal out, like you could do -1 plus the square root of 2 and -1 minus the square root of 2 and get out 2 decimals. But I would rather you just leave it a simplified radical. We have one final example. Again, I want to solve it. I want to find the values of x that make this equation true. Notice, again, I'm going to need to rearrange some things. Move this over there to be with his friends. So I just have 0 left here now. I'm going to put it in order this time. So the x squared goes first, then the x, then the constant. Okay, so -3 is a, b is -12, and c is -17. Alright, there's the formula. You've got to be careful, and I want to point out on this one, in the formula, it's -b. But notice that this b is actually already negative. So you're going to end up doing -b. And this is the most common thing I see people mess up on, is they forget to do the double negative. So the formula is negative, and then whatever b is, which in this case is -12. That's going to end up becoming a +12. Then plus or minus the square root of b squared minus 4 times a times c all over 2a. Alright, what I've written is actually going to not be correct. See if you can figure out the issue. Okay, the issue here is if I type in -12 squared to my calculator, it's not going to square the negative part. So you've got to use parentheses here so that it squares the negative and it comes out positive. So just be very careful with anytime the b is negative, that really messes people up. Okay, So negative negative 12 is positive 12 plus or minus square root. I'm going to wait on that. 2 times negative 3 is negative 6. All right, again, you can type all this into your calculator. Just be careful and make sure that's in parentheses. So it should come out as positive 144 and then all this stuff. So minus 4 times negative 3 times negative 17. And what you end up getting for all this here is negative 60. You cannot square root a negative. We'll get into that a little more later, but for now, you can't square root a negative. It doesn't exist with real numbers. So that can't happen. This is no solution. It does not have any real solutions. If you were to graph this, it would look something like this, where it doesn't hit the x-axis at all. It has no solution. And you can tell because we're trying to square root a negative, and that can't happen. So anytime you have the square root of a negative, that means there's no real solution. I want to talk real briefly, just to wrap this up, about this part right here. B squared minus 4ac. This is something we call the discriminant. Not discriminate, the discriminant, because it helps us determine or figure out how many solutions we're going to have. And you don't need to memorize this, but I just think it's kind of interesting. For example, you just saw, if the discriminant ends up being negative, then there's going to be no solution. If the discriminant is positive, then you're going to have multiple solutions, 2 solutions. If the discriminant was a 0, like let's say you had 12 plus or minus the square root of 0 over negative 6, this is going to go away. I'm not going to have the plus or minus anymore. It would just be 12 over negative 6, which is negative 2. And I would only get one solution because the plus and minus part is gone. So if the discriminant is 0, you actually have only one solution. Yeah, so there are other things you can do with the discriminant, but it's just kind of interesting.